Hello, everybody. This is a test lesson. It's to accompany the work that you're doing at the moment. It's just an alternative way. I'd appreciate your thoughts once you've had a look at this video. So, these two stickers here, what are they actually showing? You've probably seen them absolutely everywhere. They come on all different electrical appliances. When you get new things, new fridges, new washing machines, new tumble dryers, there will always be this kind of information on there. What does it actually mean? So, efficiency is a measure of how good a device is at changing energy from one form to another. All devices waste energy, so the efficiency of a device is never 100%. The more efficient a device, the less energy is wasted. Now we've got two light bulbs here. One's a more traditional filament light bulb, and beneath here is the more efficient light bulbs that we use today. So we're going to look at energy transfers in the form of money. So we're going to say we need some change for a vending machine. We've got a £10 note. What we're going to do is we're going to change that to 8 £1 coins and 1 £2 coin. Now the 8 £1 coins is useful for the vending machine. We can use that. The £2 coin doesn't fit. It's an old vending machine. It's never seen a £2 coin before. If we look at it in terms of a diagram, we've got our £10 note. We convert that into 8 £1 coins, which is useful, and our 1 £2 coin, which is wasted. 2 plus 8 equals 10. We've talked about this in the past, the conservation of energy. What goes in must come out. So, input energy, total £10. Useful energy, £8. Wasted energy, £2. Now we can express that in what we call a Sankey diagram. All the energy transfers, useful and wasted, that are associated with the device can be represented by one of these diagrams. Here we've got an example of the two bulbs from the earlier slide. So we've got the filament bulb, we've got 100 joules of energy input, 90 joules of energy wasted, 10 joules of energy useful. And the energy efficient bulb, we've got 20 joules of energy input, 10 joules of energy wasted, 10 joules of energy that's useful. Now look and notice how we've got 100 joules going in, then we have got 90 plus 10 makes 100 joules going out. And in the energy efficient bulb, we've got 20 joules of energy going in, and coming out we've got 10 plus 10 equaling 20 joules of energy going out. It's a very, very good and quick representation of useful and wasted energy transfers. The thickness of each arrow is proportional to the amount of energy involved at that stage. So if we was to draw a Sankey diagram for our £10 note, this is what it would look like. Now the important part, the height of the box represents the amount of energy that is put in. It doesn't matter how long it is. This part here is the important part. This part doesn't matter how long that is. Now the box is small 10 squares high, so therefore in this case each small square represents 10%. 10 times 10 is 100. So if we have our £10 going in, our £8 coming out that's useful, that's how we do it for step 2. Then step 3, what we'll do is we'll add our £2 that's wasted. Again, take a slight pause where we can say we have got 10 going in, 10 coming out. Now, to distinguish between the useful and the wasted energy, what we do is we give the wasted energy a different direction. Sometimes you'll see them going up, but more often than not, you'll see the wasted energy coming down with the useful energy staying parallel with the total input energy. So we add our arrows and then we label our box. But we must include the values. So here we'd have our input energy of £10, we'd have our useful output energy of £8, and we'd have our wasted output of £2. Now, there we go. This is what the £10 vending machine Sankey diagram would look like. £10 total input, £8 useful, £2 wasted. Okay. Now, if we applied the same to an energy efficient light bulb with an input energy of 10 joules, useful output energy of 8 joules, and a wasted output energy of 2 joules, it would look exactly the same. The figures are the same. Here's an example of what it should look like with our labels correctly annotated on our diagram. So here's an example of what a student's done. We've got 20 joules of input energy, 4 joules of useful light energy, and 16 joules of wasted heat energy. Again, 20 joules going in, 4 plus 16 equals 20 joules going out. Arrows are labelled with input and output energies. Straight lines are drawn with a ruler. Boxes are the correct width. Again, it doesn't matter how long it is, it's all about the width of the boxes. The wasted energy is labelled, the energy. So what I'd like you to do is pause the video now, press play when you've completed your Sankey diagram tasks. There are 4 individual tasks for you to complete at this part. Pause your video now. Okay, welcome back. So what we can do is we can look at that in terms of the pure maths involved. The energy efficiency of a device can be calculated using this formula. Efficiency is equal to useful output energy divided by total input energy. Useful energy is measured in joules. Total energy is measured in joules. Energy efficiency does not have any units. It is a number between 0 and 1. We can convert this into a percentage by multiplying that by 100. We're not going to worry about that part right now. We're purely going to focus on our numbers being between 0 and 1. Top tip, if it's above 1, you've got your numbers the wrong way round. Efficiency cannot be above 1. So here's a worked example on how to actually use this formula. So let's calculate the efficiency of the PlayStation 4. PlayStation 4 is supplied with 300 joules of electrical energy, which converts to 200 joules of energy for gaming. I've colour-coded them to make it a little bit easier to pick out the numbers that you need. So we've got total energy is going to be in red, useful energy is always going to be in amber. Now, some questions will ask you to work out the wasted energy. Well, that's a case of just a little bit of formula rearranging in our Sankey diagram. In this case, it would be wasted energy is equal to total minus useful. In this case, that would be 300 minus 200 leaves you 100 joules as heat. Remember, 300 goes in, 200 plus 100 is 300 coming out. Now, the efficiency part is a fairly easy calculation. The hardest part is picking out the numbers that you need to use. So the equation is efficiency is equal to useful divided by total. In this case, let's plug our numbers in. So we've got 200 is the useful energy, as we've highlighted here. 300 is the total energy, as highlighted here. 200 divided by 300 is 0.66 when we round it to 2 decimal places. Okay, so what I'd like you to do is have a go at this task on your worksheet now. So I've done the first one for you. It's nice and colour-coded. All I'd like you to do is fill in the missing boxes. Okay, so I'd like you to pause the video now and press play when you've completed your table. Good stuff. Okay, so what we're going to do, I'm going to quickly go through the worked example again so you can start to look through the remainder of the questions. So again, our wasted energy is total minus useful. If you wanted to rearrange that, would be total is equal to wasted plus useful, or useful energy would be total minus wasted energy. Okay, so we'll quickly scroll through that. And again, our efficiency is useful divided by total. Again, pick out your numbers, read the question carefully. If you've got the boxes right in the last one, you've proven to yourself that you can do the maths. What we need to do now is practice our skills at picking out the information we need to answer our questions. Now, there's absolutely no problem if you want to highlight the numbers in the questions on the worksheet. Okay, just to show it's finished off. Now, again, an efficiency of 0.66. Keep it to 2 decimal places. So what I'd like to do is pause the video now, and I'd like you to work through the remaining questions, including the exam questions for me. There are formulas on there to help you out. Take your time with it. I'd like you to see some of the working out for some of your answers. I can appreciate it's a little bit laborious doing it for every single one when you're using electronic resources. I'm going to leave this slide up here, so if you pause it with this slide up, it gives you the sort of go-to to go back if you need some support. So pause your video now and press play when you've completed the remaining questions. I'm including the exam questions on it. Okay, so now you've done your tasks, we can actually sort of look at this now. So what do these stickers actually mean? Well, the more efficient it is, the less energy is being used by your device. And when you consider you have to pay for electrical energy, which is what we're going to cover in our next lesson, well, that makes a huge difference. Okay, guys, so thanks for watching this video. I hope it helps. We're going to try and adopt this style of lesson delivery. I'm also going to keep putting the PowerPoints up so you can look through it in your own time as well on Teams. What I would like you to do though is have a look at this video. Tell me what you think. Now be kind. It's the first time I've ever done anything like this. I'd prefer it if you gave me any kind of feedback via your school email, please. Don't be putting things on the chat page, otherwise I'm just going to delete it. Okay? Right. Thanks, guys. Have fun doing it.